I'm Jamie King. You've probably heard that Cassandra ingests data at a high rate of speed, and that's because of the way that Cassandra stores that data when it comes into a particular node. We call that path the write path. In most database systems, the way they store that data is proprietary information. It's not known. With Apache Cassandra, it is a wide open book. And we can see how that works and see why it's so screaming here in this section. Here is our lone node we saw in previous sections. In comes the write. We're going to store some user data inside of our node. Let's zoom into the node and see exactly how this happens. At the top, you'll see we have RAM, and at the bottom, we have hard disk space. Here comes that same write. Let's just look at the data quickly. We have a key of 1. The name of the user is DevAwesome. This user lives in Texas, in the city of Houston. By the way, in this example, all the users live in Texas, and we're clustering by the city. When the record comes into Apache Cassandra actually writes that value to both memory and the hard disk. The memory data structure we call the mem table. The hard disk data structure we call the commit log. The key difference between the mem table and the commit log is that the mem table is always ordered by partition key and then by clustering column, whereas the commit log is stored sequentially. Every record will just append to the end of the commit log. At that point, Cassandra acknowledges to the client that the write was successful, and we're done. It's really that simple. Apache Cassandra writes the record both to memory and to the hard disk, and then acknowledges back to the client that, hey, I got your data. Give me another piece. Let's look at another insertion. This user's name is come2DSE, short for DataStax Enterprise. They also live in Texas, as I promised, in the city of Dallas. Apache Cassandra writes the record to the end of the commit log. Again, it's just a sequential write. We just append on the hard disk. That's easy to do. And in the mem table, Apache Cassandra inserts that record where it belongs as far as clustering column order is concerned. So, Dallas. D comes before H as far as alphabetical order is concerned, or lexicographical order, say that 10 times. And again, we acknowledge back to the client that, hey, life is good. Here comes another record. I'm going to have you pause the video here and think, where's this record going to end up as far as the mem table is concerned and the commit log? Pause the video, take a second, we're here all day. Lone node lives in the city of Snyder, which comes after Dallas and Houston, so that actually goes to the end of our memory table. The commit log, again, load node goes to the end of the commit log. We always append to the end of the commit log. Let's talk about the purposes of these two data structures. Since the mem table is in memory and Apache Cassandra stores it ordered by clustering column, then Apache Cassandra can read that data later and return it back to the user just like you see it when you do your CQL select statements. The purpose of the commit log is, hey, the node may crash, burn, go down, whatever can happen. In order to get the node to the same state it was before the node crashed, Apache Cassandra will read the commit log off disk and replay all those mutations so that we're good to go and the node's ready to rock and roll. So the memory data structure is for reading the data, and the commit logs for restoring the state of the node if it goes down and has to come back up. Here comes another write. This is I got your data. Thank you, Apache Cassandra. They live in Austin, they go to the beginning of the mem table, and as far as the commit log is concerned, they go to the end of the commit log, always appending to the end of the commit log. Now, I know this illustration makes it look like Apache Cassandra is copying values all over memory, but internally it's just changing up some references, some pointers if you're more familiar with that term. No big deal. The key point is if we need to do a read, we can do a read, get our data back sorted by partition key, and then clustering column. In this case, the partition key is the same for all of our records, Texas, the clustering columns are the city. In comes another write, always on nom 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 nom. They live in Dallas, so this one will go with its buddy up in Dallas. And as far as the commit log is concerned, it'll append to the end of the commit log. Kind of not exciting, but that's really cool because Apache Cassandra can scream when data comes in, and it's that easy just to write it. Last record, Lone Star, lives in El Paso. Insert them correctly into the right spot in the mem table, append them to the end of the commit log. Boom, we're golden. At this point, even though we have that big blue chunk of real estate at the right, let's just say the mem table is now full. There's different parameters that tune how much you can store in a mem table, and memory is a finite resource. Apache Cassandra needs to get that mem table out of memory and actually on the hard disk. So what Apache Cassandra does is flush it down to the hard drive. At that point, we no longer need the commit log. All of the data is durable on the disk since Apache Cassandra wrote it down to disk. This new data structure is called an SS table, stands for sorted string table. Literally just means the data is sorted first by partition key and then by clustering column values. Key point, this data structure is immutable. As soon as we write the mem table down to the hard drive and create an SS table, Apache Cassandra will not mutate, change, update, delete, whatever you can think of. That data is as is. Now you may be thinking, hold on, if the SS table is immutable, how do I do inserts, updates, deletes, that kind of thing? Don't worry, that's coming up in another section. Now, we recommend that you store the commit log on a separate hard drive from that you store your SS tables. Why? Well, notice the commit log, we just append. We want to ingest data. If you also have that hard drive busy with reads and writes, mutations, flushes, compaction, as we talk about in another section, then your node won't perform as well as it possibly can. So stick the commit log on a separate hard disk, especially if you're still using spinners. For purposes of the next illustration, we're going to ignore the commit log. Just know that the commit log is still going on in the background. Let's ingest some more data. In comes our records, our rows. Remember, we're still clustering by the city, so Cassandra stores all the data sorted by the city values. Oh, look, our mem table is full again. Let's flush that down as well. That makes 2 SS tables, both of which make up the entire data set of our table. In the read path module, we'll explore how Cassandra actually combines all this data up when you do a read. All right, time for an exercise. Go work on the write path, and we'll walk you through the solution in another video.